Good afternoon, my YouTube viewers. Crystal here. I just wanted to make you another video, and I wanted to make a video on the Fashion MNIST dataset, which is supposed to be a replacement for the MNIST dataset. So before I get started on the code review, I just wanted to read you something that I got off a website, off of Zalando Research website. And it said Fashion MNIST is a dataset of Zalando's article images consisting of a training set of 60,000 examples and a test set of 10,000 examples. Each example is a 28 by 28 grayscale image associated with a label from 10 classes. Fashion MNIST is intended to serve as a direct drop-in replacement of the original MNIST dataset for benchmarking machine learning algorithms. Then it goes on to say, why is this of interest for the scientific community? The original MNIST dataset contains a lot of handwritten digits. People from AI, ML, data science community love this dataset and use it as a benchmark to validate their algorithms. In fact, MNIST is often the first dataset they would try on. If it doesn't work on MNIST, it won't work at all, they would say. Well, if it does not work on MNIST, it may fail on others. MNIST is intended to serve as a direct drop-in replacement for the original MNIST dataset to benchmark machine learning algorithms, as it shares the same image size and the structure of training and testing splits. And it goes on, it says, and then they say, seriously, we're talking about replacing MNIST. Here are some good reasons. Number one, MNIST is too easy. Number two, MNIST is overused. Number three, MNIST cannot represent modern CV tasks. And then it gives you some more information. And then I think you are able to get the MNIST dataset off of a GitHub account. I did actually get my MNIST dataset off of a GitHub account, but maybe not that particular GitHub account. But I did find an Fashion MNIST dataset. So now that you know about Fashion MNIST and you know what it is, that it's intended to be a drop-in replacement for the regular MNIST, but it just has items and clothing instead of digits, we'll go ahead and go through the code review for the Fashion MNIST, and we're going to use the MLP classifier like we did on the MNIST and see how it goes. So this is basically a comparison between MNIST and Fashion MNIST. So I wrote the program on Google Colab, which is a free online Jupyter notebook, and it has a lot of libraries pre-installed on it, so you don't have to install any libraries. And then, so what we did was we imported the libraries. We imported pandas and SPD and NumPy as MP. So after we imported the libraries, what we did was we imported the CSV files. We imported the train file and the test file. So here you can see the train file, and the very last column is a Y. So Y is your target or your label. Then we imported the test file. And it's got a very last column of a Y, which is also a target. So what I decided to do, since both of the files are 785 columns with a target variable, I decided just to append the test file to the train file and make it all one file, which strictly speaking you wouldn't have to do that. You could just have a train file and a test file, but I prefer to do it this way. So if you had wanted to, you could have just trained on the train file and predicted on the test file, but I would rather do it this way. Yeah. So we look at the information on the train file, and you see that we've got 20,000 entries. No, sorry, 2,000 entries from 0 to 199. So this really is a small version of the MNIST file, because if it was the true MNIST file, you would have, I think, 70,000. But if you had 70,001, that's going to use up a lot of memory on your computer. So I think that where I got this data sets, they just used a part of it, and which is what happened with Google Colab. On Google Colab, they didn't use the entire data set either for the MNIST. So we've got 2,000 entries, and it's got 786 examples of index to Y. So now what we do is we check for null values. There are no null values, so nothing needs to be imputed. And then the next thing we're going to do is we're going to define our X and our Y variables. Our Y equals train.Y, and X equals train dot index, and Y axis equals 1. And so you can see the Y, you've got 2,000 examples, and they're all numeric. So, and you can see the X, which is 2,000 rows of 784 columns. So now what we have to do is we have to scale the data. And when we scale the data, we divide it by 255. And the reason for this is because the RGB examples are 0 to 255, and then what you have to do is you have to scale it to make it from 0 to 1 so it will fit. If you don't scale it, it's not going to work, or it definitely won't work very well. And since the values are 0 to 255, you have to divide it by 255 to make it 0 to 1. And then what we're going to do is we're going to split our, we're going to split our training and validation set, and we're going to use the sklearn's train test split to do this, and it's going to have a test size of 10%. So the X train is 1,800 examples, and the XVal is 200 examples. And now what we're going to do is we're going to define our model, and we're going to use the MLP classifier, which is what we used for the MNIST, because generally when you find a good model, it's best to stick with that model. So we trained it, and in this particular example, I had 100 hidden layers and max iterations of 100. And I had 100% when I did that. And the next thing I did was I tested on the prediction set, and I only got 82.5% when I predicted on the validation set, and that was what they said when they made the Fashion MNIST. They said that this Fashion MNIST is more difficult than the regular MNIST, which turns out to be true, because when I worked on the MNIST file, I got like a 96 or a 97% accuracy, and here I'm only getting an 82.5% accuracy. So the accuracy is a lot less on Fashion MNIST than it is on MNIST, which means you need to work a lot harder to get a higher level of accuracy. So we made a data frame, and where you can take the actual values and you can compare them against the predicted values. And what I see on this, what I see on the data frame, it all looks okay. But what you would have to do is you'd have to take all 200 actual values and then marry it up against all 200 predicted values and see which ones are incorrect. But it's already telling you that you had an 82.5% accuracy. And then what we did was we decided to use some graphics. So we put the model on the graphics using Matplotlib, PyPlot, and I can't make it out very well, but I think it's supposed to be items of clothing, and it does look sort of like people in there, but it's supposed to be items of clothing, although I can't make it out very well. So we did actually put it on a chart. So that concludes this video on the Fashion MNIST and how we have compared the Fashion MNIST to the MNIST. And the Fashion MNIST is more difficult to work with than the MNIST, which was why they made it, because they intentionally designed it to be more difficult to work with than the MNIST. But if you like this video, please like, subscribe, and share. If you want to keep receiving videos from me, then please tap the bell button. And the reason why is because if you don't watch the videos, then after a while YouTube will unsubscribe you. So if you tap the bell button, you get notification of all the videos and you watch the videos, then you'll know that you're going to get all of the videos. And if you like the work I do and you want to make a donation, I've got my email address to my PayPal account in the description box down below, because I don't have enough subscribers so I cannot monetize. And thank you so much for watching my video, and I look forward to making new videos for you in the future.